Hi class, this is number 2 on the sample problem. In this example, we're asked, suppose that a certain college class contains 40 students. Of these, 26 are freshmen and 17 are biology majors and 6 are neither. A student is selected at random from the class. What's the probability that the student is both a freshman and a bio major? Given that the student is a bio major, what's the probability that he is also a freshman? In order to capture this problem, I'm going to use a table format. Also, I want to use the table format to develop the logic behind the formulas, because I could just write out the formulas and we just crunch right through it. But I think it's helpful to understand where the formulas come from, and then it's easier to remember as you're doing the problem. So I've opened up math type and started to gather the information using a contingency table. I have biology and not a biology, and then I have freshman and not a freshman. In this example, they tell us that there are 26 freshmen, so I'll write 26 in the column. And of those 26 freshmen, they could be biology majors or not a biology major. Since there's 40 students, if 26 of them are freshmen, then we can figure out how many are not freshmen if there's a total of 40 students. 26 plus the freshman value should equal 40. So if we take 40 minus 26, we'll get 14. And again, you're not going to do this process for all the problems. This is just to show us how we get some of the answers that we do and use the formulas that we use. Similarly, let's do the same thing for the biology. There's 17 biology majors. Since there's 40 students altogether, then it's going to be 40 minus 17, which is 23. They also tell us that there are 6 that are neither. So that means they're not a biology major and they're not a freshman. So that's going to be 6. Now that I have the 6, I can fill in the other values. Again, 6 that are neither. If I take 23 minus 6, that's going to give us 17. And once I know that 17 are not a biology major, but they're freshmen, I can take that 26 minus 17, and then 17 minus 9 is going to give us. Now we've filled in the table, and I want us to observe something. I notice that the neither is black, and then the other numbers that are pink, that represents or. That's the number that are freshmen or biology or both. And both would be the 9. So we have that or is being a freshman or being a bio major or both. So it turns out neither is the complement to or. So let's capture that using math. So we have the probability of B or F is 1 minus the probability of neither B or F. In this particular case, that's equal to 1 minus 6 divided. We can get a common denominator. So notice that you can just take the denominator and subtract the numerator, 40 minus 6, which will give us 34 out of 40. So if we have neither to find or, we just take the denominator minus the numerator. That'll give us, in this case, 34 divided by 40. All right, so now let's go out and do the original problem. Suppose again that we have a certain college that contains 40 students, 26 are freshmen, 17 are bio majors, and 6 are neither. So the probability of being a freshman is the probability of being a bio major is 17 out of 40. And the probability of being neither a freshman or a bio major is equal to. So now we know the probability of being a freshman or a bio major is equal to 1 minus 6 over 40, since neither and or are complements. And we said to find 6 out of 40 subtracted from 1, we just take the denominator, which is 40, subtract the numerator, which is 6, so we get 34 over 40. Now we can do our problem. The first question asks, what's the probability that a student is both a freshman and a bio major? So we know that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. On ALEKS, they use the notation for A or B and they use the union symbol. And then for AND, they use the AND symbol. In our problem, we're asked to find both freshmen and a biology major. So we are really after this expression, the probability of A and B. And it turns out an equivalent way of expressing probability of A or B equal to the sum minus the overlap could also be represented this way, that the probability of A and B is equal to the probability of A plus the probability of B minus OR. So now looking at our table, we can see that if we take OR, which is the probability of being a biology major or a freshman, biology major is going to be this column here. We'll call this Biology Boulevard. And we'll call this Freshman Avenue. And we can see that if you take Freshman Avenue, that's 26 total. And if you take Biology Boulevard, that's 17, but we're counting the 9 twice. So that's why we subtract the overlap. So the probability of bio plus the probability of freshman minus the and, that's where they overlap, so we don't count the 9 twice. Using some algebra, we then show that the probability of A and B, by adding a probability of A and B to both sides, when we do that here, plus the probability of A and B, we notice on this side the probability of A and B are going to cancel because we have it subtracted and added. Now I'm going to subtract the OR from both sides. And then on the left-hand side, the probability of A or B, the probability of A or B. Here there's added and subtracted, so they're going to cancel, leaving us with a plus the probability of A and B, which is just the same as probability of A and B. So it turns out the formula for the probability of A or B, I should have written down the original. It turns out it's equivalent to interchanging these two. If you switch the A or B with the A and B, because that's what we did, we added the right-hand side, probability of A and B, and then we subtracted the left-hand side. So when we added, the P of A and B goes over on the left. When we subtracted the probability of A or B, it then goes to the right. So that's an equivalent formula. So we're going to use this formula to solve for A and B, because remember, we don't have that chart. So the probability of a freshman and bio is equal to the probability of a freshman plus the probability of a bio major minus the probability of OR. The probability of being a freshman is equal to 26 out of 40. Substituting in our values, probability of F, which was 26 out of 40, bio, 17 out of 40, and earlier I had typed in 7 out of 40, but I caught that and fixed it. And the probability of F or B, which we derived from the 6 out of 40, was 34 out of 40. Subtracting 17 minus 34, I did those two first, believe it or not, got negative 17. And 26 minus 17 is 9. So we get 9 divided by 40. That's for part A. Part B says, given that a student selected as bio, what is the probability that he is also a freshman? So I'm going to teach you a wonderful way to make sure that you get this second question correct, and it's being able to translate. So we're going to take the word given and represent it with a vertical line segment. And then whatever comes after the given is going to be either bio or freshman. In this particular case, is given bio. We're going to write that vertical line segment and then the letter B. So that's how you would translate that English statement. So that's given B. And then it says, what's the probability that he is a freshman? Another way of saying it is, what is the probability that he is a freshman given that the student is selected as a bio major? But we've already captured the given bio. So to capture the probability, we use the P button and then F for freshman. So we're really asked to find what's the probability that a student is a freshman given that they're a bio major. And so that mathematical notation is the way we capture that English statement, given that a student selected is bio, probability, freshman. So we have it here. Well, there's a formula whenever we have a conditional probability. And the formula for conditional probability is the probability of F and B divided by the probability of B, whatever that given is. F and B, that probability was found in part A, which was 9 out of 40. And then the given that their bio major was 17 out of 40. So we're going to take the 9 out of 40 and divide it by 17 out of 40. I think I got a little excited. What do you say with all those ones? Whenever we're dividing fractions, we always invert and multiply. So we're going to multiply by the reciprocal of the denominator, which would be 40 over 17. The 40s will cancel, leaving us with 9 out of 17. If we look at our table, it will also make sense. But again, when we're doing the next example, I'm going to do one more of this type to show you that it doesn't take this long. It's because I explained it all. But if you look at the table, you'll see something pretty cool. Given that you're a bio major, that means you're only staying on that bio. Forget if I called it highway or avenue or boulevard and avenue. Let's go back up here. Yeah. So we're on this bio. I believe this was boulevard. Maybe it was highway. So if we're restricting ourselves just to the bio highway, that we're saying, I only want to look at the freshmen. There are 9 of them. But it's out of the 17, and that's what we got for our answer. So 9 out of 17. All right, so let's put in those answers, and then let's go ahead and do another example. So this one was 9 out of 40. And this one's 9 out of 17 because we restricted the major. Instead of looking at all students, now we're only looking at bio majors. So let's just do another example so you can see that it doesn't take that long. So in this example, we're just only going to look at the, I wish we could just only look at this part here, but that's okay. So we have 51 students, 26 of them are juniors, and 30 are social science majors, and 5 are neither. So let's capture that using math type. So 26 are juniors, so the probability of a junior is 26 out of 51. The probability of being a social science major is equal to 30 out of 50. The probability of neither is 5 out of 31. And therefore we can compute the probability of or. And if we take 51, which is the denominator, minus 5, we'll get 46. So the probability of or is 46 out of 51. The first question asks the probability that they're both a social science major and a junior. So it's the probability of a junior and social science. And we said that to find the probability of and, we just add and subtract or. So we're going to take that 30 out of 51 plus the first one was J, which was 26 out of 51. So we're going to take the 26 out of 51 plus the 30 out of 51. And minus the 46 out of 51. So 26 and 30 is 56, and 56 minus 46 is 10 out of 51. So we know that the probability of being a junior and a social science major is 10 out of 51. So that's our first answer, A. And then our second answer says, what's given that the student is selected as a social science major, what's the probability that she is also a junior? So here it says given social science. So if we're given social science, so that vertical line is going to represent our given. And we want to know the probability that they're a junior, so that junior is going to go first. And our formula says that if you want to have a conditional probability, that condition that they're already a social science major, what's the probability that they're a junior? It's going to be the probability of J, which is a junior and social science, divided by the probability of what? Well, whatever that given is what's always in the denominator. So that's going to be the probability of being a social science major. So whatever that given is always in the denominator. So it's going to be 10 out of 51 divided by the given. And the given was social science, which was 30 out of 51. And when we invert and multiply, the 51s are going to cancel. So that 51 in the numerator will cancel with the 51 in the denominator. Excuse me, it's actually the 51 that's in both of the denominators, one in the numerator and one in the main denominator. So those 51s will cancel, and you're just left with 10 out of 30. Or you could reduce it to equal 1/3. I think ALEKS will take both. So the first answer is 10 out of 51, and the second one will be 1/3. So I hope this movie on number 2, which is on conditional probability, was helpful for you. And I think we do have the little answers there. Yep, 10 out of 51 and then 10 out of 30, which they do reduce.